What's up guys, my name is John and today I'm going to show you how to upgrade your standard LiPo charger with a new firmware using the Cheali Charger firmware. So as you see, it's running the Cheali Charger open source project which upgrades these types of standard LiPo chargers. There are tons of variations of these, but they are basically all the same. So why would you want to upgrade your charger? Well, there's not many reasons. My reason is I want to charge lithium polymer high volt batteries, and as it is, this charger doesn't support them. And you get much more detailed information in the firmware than in stock. You get the cell resistances, you get just a bit more options, and I think it's a better software overall. And yeah, you could charge any battery. You could just set up your custom batteries in the software, and it's very easy. So basically that's the reason. If you want to charge lithium high volt, then you need to upgrade these chargers, and they work perfectly fine then. So you don't have to bother buying a new one. But who should do the upgrade and maybe who shouldn't do the upgrade? Well, if you know what an Arduino is, you should really know what it is. If you don't know what an Arduino is, you can just buy a new charger which supports your features. Probably it's too much hassle for you, and you're willing to accept the risk that you may break your device in the process. It also will take around 1, 2, 3 hours depending on your skill level and luck. And your charger has to be compatible. Now the Cheali Charger supports, I think, 2 types of microcontrollers. One of them is the Atmel 32, which my charger, the IMAX B6, is running. So I'm gonna show you how to check if your charger is compatible, but you will have to click on the link below from the official Cheali Charger GitHub page, and then you can see all the models that are supported and that have firmware for it. So first of all, I would check that. So the basic steps to upgrade your charger is you have to open the device, check what processor you have in the device. You have to download the firmware from the official GitHub page, then download AVRDUDE, which will be used to write the program onto this processor. You have to configure your Arduino. Then you have to configure your Arduino as an Arduino as ISP, which is very easy to do. I'm gonna show it to you. And once you have done that, you can flash the firmware through the Arduino onto this charger using AVRDUDE. And once you're done with that, the very most important step in this whole process is to calibrate your charger. You cannot skip that step, otherwise your house may burn down. So yeah, that's it. That's a basic introduction. Now I'm gonna get started by opening the charger and checking the firmware. If you want to skip this step, I'm gonna make timestamps in the video, and you can just skip down below to the step you want to see. But first of all, we're opening the charger. So now that we have opened this charger, you can see that here is the display, and underneath this display sits the processor. Now we have to check what processor our charger has. What you're looking for is an Atmel 32. If it's anything else, then this tutorial may not apply to your charger very well. and not all MCUs are supported, so make sure to check on the official page that your processor is. So if you pry this open, let me get the little flashlight. You can see this guy here, and I have no idea if you can read this, probably not, but in real life I can read it, and this is an Atmel 32A, which is basically just an Atmel 32. So make sure to check your processor, and if it's the Atmel then you're lucky, then you can continue with the firmware upgrade. So you will have some pins on here. These are the programming pins, and it depends what charger you have. You have to find out which one is which pin. On the official Cheali website, you can, on the GitHub page, you can check the pins. Which one is meso, MOSI, serial clock, reset, etc. You can check those, and it's also very important to know what charger you have. This is a genuine IMAX B6. If you have a knockoff, the pins are going to be different, and if you mess up the pins, you can completely destroy the charger. So make sure that you have the correct model, and on the official page you can find out if you have the IMAX B6, if you have the genuine one or the fake one. I think the crystal is on a bit different spot. You will see. So once you have located these things, you have made sure that you have the Atmel chip, then we can download the appropriate firmware for our charger. So let's hop over to the computer for that. So here we are on the official Cheali Charger GitHub page, and we're gonna look for our hex files for the firmware. So you scroll down until you see flashing. You click on flashing. Here you can see the programming pin layout for different types of chargers. Here I have the original IMAX B6. You see here what I was explaining with the crystal. You can identify yours, and make sure you know you have the right one, because as you see, the VCC pin here is the right one. Here the VCC is the right, the left one on the clone. So make sure you have the right one. Otherwise, you're gonna fry your charger. So you can find your hex file in code in the hex page, and just look for your charger. And mine is the IMAX B6 50 watt, and you're gonna look for, this is the Nuvoton processor. We're gonna look for the Atmel processor, 50 watt. This is the Atmega 32. Here, Atmega 32 hex. You open this file, you copy it, then you open your notepad, paste it, save as. You create a folder, which I have already done. So documents I have created here, firmware, and I have put my firmware here. So I will just, I saved it here because I already did the upgrade, but I'm gonna do it again for this video. So you save it as a hex file. So you just write a name for it, any name you like, and then you write .hex. And if you save it, then you have your hex file. So now that we have the correct firmware for our charger, we have to download the programmer which is called AVRDUDE. So let's look at this page, and here we can find AVRDUDE. We have to click here and download the correct version, which is this one, AVRDUDE 6.4 mingw32.zip. So you download this, which I have already done, and then you have this AVRDUDE.exe. You're not quite done yet. You can't just click it and run it. That doesn't work like this. You have to go onto your computer and you have to set it up by going to Properties, Advanced System Settings, Environment Variables. So you click on Path, Edit, and you're gonna do a new one, and now you're gonna look for your folder where you downloaded the AVRDUDE. So it's probably still in downloads for you. I would recommend to create a new folder. I created one in Documents under a new folder which I named Firmware, and then I did an AVRDUDE. So you copy your path, and as you see it's already here, but I'm gonna create a new one anyways here. So you create your path. Because I have already created it, I leave this. You press OK, OK, OK. So you have AVRDUDE ready to go. So now that we have done our AVRDUDE, let's configure Arduino as ISP. So you have to open your Arduino, go to Files, Examples, Arduino ISP, and open this example. Now you just plug in your Arduino. So I'm doing this now, physically plugging in my Arduino here. You hear the sound going off. You choose the right one. It's important to remember the COM port that you're on. So COM9, let's remember this. And we just upload this code as it is. And this will allow us to program our charger without having an actual Atmel AVR programmer. So now that our code is done uploading, we can hook up our Arduino to the charger. So for hooking up our Arduino to our charger, we will look at this document. So just the GitHub page of the Cheali Charger, and we're gonna look at the flashing part. And here you can see the different diagrams for different chargers, and we're gonna hook up ours like this. Serial clock left here. So let's just do this, and I'm gonna show it to you on the job. So for hooking up the ISP pins from your Arduino to the charger, I soldered a header here. You don't have to do that, but I think it makes it easier and less finicky, and it's less likely that something's going to go wrong. So I recommend you to open the GitHub page for the programming port, how it's laid out. I have to look at the IMAX B6 original, maybe you have to look at another one. And on the other screen I have the Arduino pinout. So with this I'm able to hook it up. Digital pin number 13 is serial clock, 12 MISO, 11 MOSI, and pin 10 is reset. So not the reset pin of your Arduino is reset, but pin number 10 is reset. And check this thoroughly that it's hooked up correctly, especially VCC and ground, and make sure that your reset pin from the Arduino comes from pin number 10 and not from the reset pin of Arduino. Maybe confusing, I did the mistake and it didn't work. So if you have hooked up this, then we're almost ready. So double and triple check if you have hooked it up correctly, because this is the point where you can mess it up. So we come here to the computer and I check again, and I'm gonna be back with you shortly. Okay, I have double checked my pinout. We can hook up our... I can't do it with one hand. So we have hooked up our charger. Of course, on your charger, because you don't have the firmware yet on it, it's gonna tell you that you have low voltage, but that's okay. So now we're gonna hop back to the computer and load our new firmware using AVRDUDE. So see you soon. Okay, now that we have hooked up our charger to the Arduino ISP and we have double checked the connections, we can look at the flashing page again. You're gonna have to have this open on your other screen or with another tab, because we're gonna just copy paste this code. So now we're gonna look in our folder that we have created, which is, for us, it's in the documents and it's here, firmware Cheali Charger. We already have documents here that I have created before. We're gonna put these away, so these don't exist yet. Now you click on the top here on the path, you just write CMD, enter. Now let's make this a little bit bigger, like this. So, because we're using Arduino ISP, we will not use the CUSBASP programmer, we will be using these options. So the first two lines of code is to just create a backup. I don't know if it is even necessary, but let's just do it. Oops, here. So we copy this, copy, paste. Then we copy this on top here, copy, and we are gonna look for the CUSBASP, and we're deleting this. We press paste and we rename this to remember COM9. That's our COM port. And as soon as we have this, it will create our backup files. So press enter and it will start reading your configuration from your Atmel Atmega32 chip. And it will create some bin files into this folder that you have created. If you have an error message which is device signature equals 0xFFF000 or something like that, then you have probably hooked up your device the wrong way if your device signature isn't recognized. And also don't change anything to these to this code, anything besides the programmer here, because you can actually brick your device. So we copy this again, we create the other backup, so we press paste, we copy this programmer again, we delete the programmer which is used for the Atmel AVR programmer. We don't have that, so we delete it. If you have the programmer, you can leave it. COM9 and read the backup. So it's doing its thing here. And if we look in our folder here, you see the new bin files which we have created using AVRDUDE. So it's reading our backup. And great. Wow. Now we come to the fun part. We copy this code which is to write the software into our device. So we do copy, paste, you take the file version, so u flash w and you will enter your file name. For us it's, I have to check, oops, that's the wrong one. For us it's Cheali IMAX B6.hex. So Cheali IMAX B6.hex. Again, change our programmer to this. Just double check everything looks good. And now we press enter. Oh, of course we tried to. Okay, I forgot to change the COM port, so we do this again. So we paste this. Actually, you can press the arrow up to get your last command line back, and we change the COM port to COM9. So we check it again. It's correct. We press enter. We can make this full screen, and it's writing the code onto our charger. So this will take a few seconds. And after our code is done, we will be greeted with erase EEPROM 15 yes screen. And if you have that screen, you have successfully flashed your firmware. Then you do nothing yet. So let's change back to the camera. We're done flashing. Let's go back. So here we are. We have just finished flashing our Cheali Charger firmware, and we're greeted with the screen EEPROM reset 15 yes. At this point, you can unplug your device. You can unplug the programmer. And my power supply is here on the floor. So we're plugging in our power supply. And we have the Cheali Charger version whatever on this device. Erase reset EEPROM. We press yes. And now we will have to calibrate this device. This is an extremely important step, because if you don't calibrate your device, you're gonna have the wrong voltage and current readings, and you will probably burn down your house. So it's very important to do this step. You cannot skip on this step. It's just don't do it. So, after flashing the firmware, the most important step is to calibrate the device, and when you power on your device, you will be greeted with this screen. So first of all, before you do anything, make sure you have a battery that's around half charged, and you have your multimeter that is capable of measuring volts and amps. So the very first thing you do is measure your input voltage and write it down. So input voltage is I have to switch to volts. 12.3. You write this down on a paper. I have already written down everything because I have recorded this part and forgot to, well, I have tried to record it and forgot to hit the record button. So I have done it already, everything. After that, you have to measure your individual cell voltages. So measure your total voltage, write it down on the paper. Then you measure cell number 1, which is, it always starts with the black one. This is cell number 1. With one hand, it's incredibly difficult without shorting it out. It's basically impossible. So you measured cell number 1, cell number 2, and cell number 3. You write it down on a paper, like I did here. So you see 3.806 is cell 1, this is cell 2, this is cell 3. And after you have this is all the data you're gonna need. Plug in your device. Go to options, go to calibrate, and voltage. You connect your battery with the lead here and with the balance leads, like this. Now you will write your input voltage, which for me is 12.3. You can change the value by hitting enter and going up or down. Then you change your voltage 1, you change your voltage 2 and voltage 3 accordingly, because I have already messed around with the battery already a little bit. The values aren't exactly the same that you saw on the paper, but that's okay because I have already charged the battery somewhat. So you have calibrated voltage successfully after setting up the V-in, the battery cell number 1, 2, 3, or how many ever cells you have. You just have to adjust it to the rate that you have measured. So now that your voltage is calibrated, you calibrate the charge current. First of all, unplug your balance lead, leave this lead, and you have to connect a bridge through your multimeter. You can do it however you would like to do it. I do it in this way. I unplug one of the leads from the charger and I plug it into my multimeter. And then basically the charge leads come out from here. I plug it into here. I turn it over to amps. I hit, let's arrange this a bit better. And I hit current charge calibration start. We start at 50 milliamps. And you will have some value here. I have already happened to calibrate it because I recorded the video without recording it. So you hit enter and you will see that current is starting to flow through your multimeter. Now in the beginning it won't be accurate. I had around 20 milliamps flowing through. I'm going to change to my more accurate milliamp reading. So in the beginning I had around 20 milliamps flowing through. Then I have calibrated and now I have 50. So the goal is to change this value until you reach 50 milliamps. My values are kind of jumping about. So you see 49.7, we can increase it a little bit to 700 and now we have overshot. $755, we're looking at 750 is around 50 milliamps. So we take this new value, this is the calibrated value. Now we can change to our amps and we calibrate for 1 amp. In the beginning I had also some different value. I had around 1.05 amps flowing through. Now that I have already adjusted this value, it's bang on 1 amp. So it's calibrated. You can change this value with the up down arrow till you see 1 amp on your meter. Great, so now we only have to calibrate the discharge current. Also starts with 50 milliamps. Let's plug it into my more accurate reading for smaller amps. Start. Here you see it's bang on 50 milliamps. If you change the value, of course, your milliamps are gonna change. But we want to be at 50 milliamps. So we accept this value, go back, do the exact same thing for 300 milliamps, start, and you see we're already a little bit off. We can adjust it. Perfect. We accept this value and we're done calibrating. Enjoy your charger. Now I can also show you a little bit of a tour in the options of the charger, what you can do. So these numbers are basically your battery slots. So let's set up one of my batteries. Edit battery. We want a lithium polymer battery, but as you can see, we have these lithium high volt batteries, these L430, L435. What it means that the battery is going to be charged to 4.35 volts. In this one, the battery will be charged to 4.3 volts. This is the reason I did the upgrade, because I want to fly my drone with a lithium high volt battery since they're a bit more efficient and a bit lighter. But we're gonna set up our lithium polymer now. 3-cell. Ours is 4-cell. Yes. Then we have our capacity is 850 milliamps. We're gonna set it to 850. Yes. Charge current, we want to charge around 1.2 amps. This charge is okay. And we will set a time limit to around 1.5 hours or something like that, 80 minutes. So if it doesn't charge in 80 minutes, something's wrong. And we have successfully set up our first battery. So here we have our LiPo, and we could charge it, but they are fully charged. So let's set up this battery. We're gonna set up our battery number 2, edit battery. We're gonna use again a LiPo 3S. Yeah, that's good. Capacity is 2200. Charge current 1C is fine. This is fine. Limit. Again, I like to set around 80 minutes because most batteries should be charged in an hour, even at 1C. If it's not charged at 1C, if it's not charged in 90 minutes, something's wrong. Okay, now we can plug in our battery. We can charge and balance. And we have started charging. So here you see the charge current, the battery voltage, you see the time that has been elapsed, and then you have the milliamp hours charged here. In the next screen you see the watts with how many watts it's charging, and I think by mistake I'm charging with 220 milliamps instead of 2200. Oh, now it's increasing, so I said nothing. And we see the cell balances here, and it also is showing you which cells it's balancing at the moment. So the battery icons are gonna appear if the cells are out of balance, and you will see, yes, it's charging or draining cell 1 and 3 because they're too high. You see the internal resistances of the individual cells, which is also nice. So you see a bunch of data. That's pretty cool. Now you see that we're charging at no, that's something different. Here we're charging at 2198 milliamps, 25 watts, and we've already charged this much. We see the voltage, so it's quite a neat software. You can charge lithium high volt batteries finally. You didn't have to spend any money probably, and you can just preset your batteries that you already own. You can set these battery profiles and just charge them. So it's basically a battery charger. It's pretty cool. You have more data than before. I didn't see the internal resistances, for example, or which cells it's balancing. I never really knew if it's actually doing the balancing or not. So it's quite neat that you see how it works now. So I hope I could help you set up your charger and charge a lithium high volt or whatever you do. And if this video has helped you, make sure to let me know. It would make me happy if I could help somebody. And then subscribe, leave a like, whatever. Have a nice day.